Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show we're going to be taking a look at the Raspberry Pi 5. We're going to be checking out Raspberry Pi OS as well as Alpine Linux just to see exactly how it performs. So let's get right into it. Okay, so this is the Raspberry Pi 5, and I just got this. It's inside of the official case, and from first look, it does look a lot like the Raspberry Pi 4, but there's a couple of differences. So if I actually take it out of the case, what I have on here is the required cooler. Now, it doesn't have to be this cooler. This happens to be the official Raspberry Pi cooler for the Raspberry Pi 5. But you could use different types of coolers, things like that. They make Ice Tower, things like that are still quite usable, as well as using smaller heat sinks and more powerful fans. This one leaves a little bit to be desired in terms of not being as quiet as some of the other Raspberry Pi versions that didn't require it, but, you know, it's a trade-off between performance and noise, and, you know, the ergonomics associated with it. So it does have the onboard fan header, which is really nice. You don't need a hat to be able to provide that, and you don't have to consume your GPIO pins in order to do the same. For previous versions, like the Raspberry Pi 4, you had to actually use that in order to be able to keep the processor cool unless you had a very large heatsink. So that is definitely a huge advantage. But something I do want to note is that for PoE, the headers associated with the PoE power that would usually connect to a hat are on the opposite side. So if we look at, for example, here, let me get a Raspberry Pi 3. Well, I was going to. Unfortunately, it doesn't have those headers. And the other one I have to unscrew. So I can't compare it, but point being, it actually does have a different hat format that it will need and a different PoE hat that won't be compatible or interoperable with the 3B Plus or the Raspberry Pi 4. So definitely a little bit of a drawback in that regard, but I believe they did it because of being able to fit additional I/O, and also the heatsink form factor and everything else like that. The heatsink itself actually fit on very easily, so it's just some press pins that are have spring retention, and there were just some thermal pads underneath to actually convect the heat out from the actual processor to, and also the RAM and the South Bridge, which is the RP1 controller, which is brand new on this particular model of Pi, to be able to actually drive that heat away. Something we'll try out later is actually using this PCIe expansion. It has a small ribbon cable, kind of like what we have for the camera on the Pi Zero. Similar size, but I don't know if it's directly interoperable in terms of pinout or a number of pins, for example, but it is very similar in size. So they haven't released, at least as of this live stream, they haven't released that particular hat to be able to add like an NVMe storage or an actual PCI Express lane, but I know a couple of people have made videos about it just in regards to trying out graphics cards, things like that. So that's a very good step forward in terms of adding a lot of flexibility that other devices have been adding in, you know, as far as the competitors to the Raspberry Pi that they haven't previously had. The most we had was the USB 3. And on this new version, the USB 3 actually has, you can saturate 5 gigabits per second. It's just 3.0, USB 3.0 on both, excuse me, on both USB ports simultaneously. So through the South Bridge, it actually has a multi-lane connection. It does extend one of the lanes out here, so this is only one lane if you hook up NVMe, which is still better than 0 lanes, but effectively you get a lot more bandwidth on your front panel I/O than you would otherwise. So not everything is competing for bandwidth as it was on previous versions, so that's a good way to remove a lot of the bottlenecks. And just overall, it's a lot faster. So the processor is over 2 gigahertz, which makes it over double the speed 2 to 3 times is how they advertise it, the speed of previous models, as well as some other optimizations because it's a later model CPU and GPU with onboard GPU. So it's a very nice thing. Still has the SD card, USB-C, and it does require a lot of power. Pretty much a 5 amp power supply is required in order to run this. It does have headers for UART and a real-time clock battery. I don't have one with the right connector, so we're not going to try that out today. But that is a really nice feature to add as well, since a lot of other boards already integrated that previously. So this is actually not the one we're testing. This is a 4 gig model. So I have 2 of these, and we'll in the future try out some projects where we try to maximize the hardware for more advanced processing loads, like doing video and things like that, to be able to actually see what we can use this for in terms of more advanced projects than we could use the Pi for. But today we're just going to be taking a first look. So let's go ahead and boot up. We're going to be checking out 2 operating systems. The first one is going to be Raspberry Pi OS. And of course, this is the first party OS that we would actually be checking out. And while it boots up, I'll just show you this really quick. It actually has a power button, which is something it never had previously. So, that's something nice. So if you shut it down, you can press the button. You get a nice satisfying click just to let you know that you're turning it on and off, but that's actually on the board itself. So now we're booted up into it, very quick, just while I was talking there. So this is the OS, and realistically, if you've ever used Raspberry Pi OS before, it's still Plymouth, so it's still using pretty much the same interface they've had for a long time. And a lot of the same features in terms of programming. It comes with onboard Thony, so you can program the Pico microcontroller. It has Internet Browser, Chromium, or Firefox, so you use the one you like. VLC Media Player pre-installed. The graphics, just an image viewer, which pretty standard. It's able to create and read archives, calculator, all of this stuff. It can also, it has the imager pre-installed, so you can create other image SD cards for other Raspberry Pis, which I think is actually very nice, as well as an SD card copier. So if you ever want to create backups of your SD card, you can use a Raspberry Pi to be able to do that pretty easily. And then Task Manager, Terminal, and Text Editor. So pretty straightforward. In terms of help, pretty standard resources, mainly online. And then in preferences, we have the ability to add remove software. We have the print settings, Raspberry Pi config, recommended software, and screen configuration, etc. So let's go in and let's add some software. And this is one of the nice things, is it's kind of like an app store. So it's a way to visualize the repositories that are available for Raspberry Pi OS. So let's actually see what we can do in terms of benchmarking this. All right, we're going to apply. I'm going to type in my very secure password. And one of the nice things, just as if you haven't used Raspberry Pi Imager recently, it is definitely a lot easier to get everything set up because you do a lot of the pre-configuration inside of the Imager itself before you actually run it for the first time. So setting the default password, everything else like that, you can make sure that it's secure out of the gate by not having a known password that people could find online. So that's definitely very helpful. So now this is installed. Let's see if we can run it. We'll do some basic tests really quickly first. So as far as Suspense, pretty much you just run it without whatever flags for the things that you want to test, for example, CPU, memory, etc. And the Raspberry Pi 5 has a lot more specs in terms of all of these. So let's see what it's actually able to do. And we're just going to do a basic test first. While this happens, I do actually want to pull up and just make sure it's actually running as expected. So we're going to pull up Task Manager as well, just so we could see all core, CPU usage, everything else like that. And just kind of keep it over here to the side. And for this, we'll just put this, see if we can squeeze it all in. I think that'll work. So we'll do sysbench -- test equals CPU run. So it's starting its threads. Right now we see it's only using 25% CPU usage, which tells me that it's only using one thread. So we'll probably need to specify that we want it to do additional threads as well. And if we go through the results that popped up, we do confirm that it was only using one thread. But that was actually very fast for doing the first 10,000 numbers. So events per second, 2,732 and 0.69. So pretty good. So let's actually see if we can speed that up even more by using all 4 threads. So I'm going to do threads equals 4. Now we see it using 100%. There's a little bit of heat coming off of here. It froze for a second and then it came up, although I did touch it. Oh, that may be me. Let's run that once more without me perturbing it. But there is a bit of heat coming off of it now. And the fan still not going maximum speed, or at least as loud. It's not as loud as it was when it was starting up. But, you know, I think that overall, that's a significant speed improvement versus single core versus multi-core. Where before, yeah, we had 2,732 events per second. Now we have 10,897, which we would expect it to be a 4-fold increase in effect, and we did confirm that on the second pass. So it is very consistent. It doesn't look like it's throttling at all when it actually is using all cores versus using a single core. But I do think that, you know, in terms of a theoretical workload, because obviously, unless you're doing transcoding or something of that nature, it's never going to actually operate like that. It's not a real test just because it doesn't really emulate necessarily a particular workload. I mean, in terms of if you're computing prime numbers with this, it's an excellent test since that's what it's actually testing. But, you know, higher is obviously better because the more passes, the more numbers it can get through, the better chance it has to be able to actually reach the number that you want. So I think that's definitely a pretty good number. Let's try something else. Let's try RAM. See if it will do it. Wrong word. It's memory. So we're still using 4 threads because obviously we want to max out the CPU usage as it's hitting the RAM. We could try it on single thread and see if that changes the equation as well. But total number of events, so it's showing about 9 gigabytes per second up here. So in terms of what the actual amount transferred across the time it was running, which was about 10 seconds, yeah, we got almost 90 gigabytes transferred. So that's a significant improvement. It's DDR4 versus DDR2 and DDR3 for the Pi 4 and Pi 3 respectively. So I think overall, definitely a marked improvement in terms of potential capability for being able to utilize it for graphics workflows as well as other things. So that's very nice, and I think, you know, it's excellent. You know, no doubt about it, more is better in terms of the available resources that have come into play with the Raspberry Pi 5 versus the previous generations, and it's nice to see a refresh of the overall product line, and also the availability now that they've actually become available generally. So that's also really nice. So, all right, so I think that's a few things right there. I don't know if there's anything else that we want to test. Let's just load a web page and play a video, which I think will be a much more practical test. So let's do youtube.com/@extendedgreg. Oh, we're live right now. So let's try and play some kind of video here. And we see the response is actually very good. I mean, yeah, in this case, I don't believe it's actually outputting through HDMI. Oh, it is, but it's not capturing. Oh, because I have it muted. Yeah, so it is there. I have it turned way down just so that way it's not competing. But we could see it's playing. As far as the actual frame rate, everything else like that, we'll go to Stats for Nerds. This is the lowest resolution. Let's see if we can bump that up a little bit. So we go to full screen. I don't know why it's doing this particular closed captioning. Let's take it up to 1080p. It's doing one of the translations opposed to it being in English. I don't know why. But we see it's handling it. So it's doing 1920 by 1080 at 24 frames per second. Everything is running normally. I don't see any dropped frames, anything else like that. Even with effects, animations, things like that. So, you know, a little bit glitchy here and there, but overall, I think the performance is excellent. You know, it's not a, you know, it's, I don't know that it would be as competitive to today's regular computers as anything else, but, you know, it's certainly a computer from a couple years ago, and it's more than usable for everyday workloads, which I think the Pi 4 was starting to approach, but wasn't quite there yet. And, you know, I definitely tried it for certain tasks, like especially programming on Linux and things like that, and ended up having to use a VM. But I'm going to take another look at that and just see if that's still the case, because it makes it a lot easier to program Linux on Linux. And I think that having this environment to be able to do it would be more than adequate for my needs. So let's close out of this. Let's shut down. Let's move on to the other OS, which is the Alpine Linux, which is headless. It runs from RAM. And I think it's actually going to really shine just because it's not going to be reliant on the speed of the SD card to be able to actually go through and do a lot of the processes. So I think that's going to give it a huge jump because of the DDR4. So let's see. So Plymouth is shutting down and it's off. So it's very quick in terms of what it can do. So I'm just going to put in this other SD card. We'll power it up really quick. And this is actually a faster SD card itself. So this is a Samsung. The other one was a generic Micro Center. Cheap one. I mean, it's still class 10, things like that. But I believe that this one that's currently in there is a higher grade. I did go ahead and pre-configure this just so that way we didn't have to go through that. This is the new version 19, which was recently released. So a couple of things actually are different. Setup Alpine is a little bit different and a little more intuitive. So, you know, I think overall it'll be a nice little step forward. But we're gonna probably, as we go into it, I may make another tutorial about how to configure it, but that's for another day. So let's go ahead and do APK update. Right, we have 22,000 packages available. Now, one thing I do want to mention is that on the Raspberry Pi 5, Alpine Linux has to be AArch64. I tried running the other variants and they did not run. And even then, they say technically they don't. The other versions, which is the V7 and obviously HF, but the V7 isn't supposed to run with the Raspberry Pi 4 either. It does run in a lot of cases, and maybe they'll make it so it runs, so you have more access to more of the mainstream packages in the future. But we are on AArch64, so we don't have access to all of the packages that we ordinarily would. So just something to keep in mind. So let's go ahead and install Sysbench. So let's do Sysbench --test CPU run. It's going to do single thread performance once again, but this time obviously the entire thing is running from RAM. Alright, and it's a couple hundred lower, but at the end of the day it's still a reasonable thing. So CPU speed came back at 2500 instead of about 2700. So that's fine. Let's go ahead and do it with 4 threads. So since it's a 4-core CPU, should be quite a bit faster. Last time it was almost 12, I believe it was 10,197. So this time it comes back with 10,062. So again, a little bit slower. So obviously Raspberry Pi OS is going to be more optimized. And even though it's a graphical, it's a GUI, it has a GUI, it's going to still potentially be a little bit more optimized for this hardware, whereas Alpine Linux is going to be more consistent across a larger swath of hardware. So, the performance, there is a minor performance impact, but I think it's pretty comparable. But that's only as far as the CPU. I think as far as some of the other read-write tests, things like that, it will probably be a bit better because it's running out of RAM. So let's try that. So let's do memory. Let's see what we get. Last time we got about 8.9 gigabytes per second. And we got 8.6 here. So it's still pretty comparable. It's a little bit off. So obviously there's some additional overhead or things like that, or potentially bottlenecks that are not being accounted for here. So certainly something to keep in mind. And, we'll have to see if there's a way around that to be able to match performance or even improve it. But still, it's a very solid showing for a third-party OS. Something I did want to try is just seeing potentially what its encoding rate was. So let's see if we can actually just repeat one of the examples that we did. So previously we tried to encode a webcam. So we could do FFmpeg, which let's add it really quick. And pretty much what we're going to be doing is just downloading and installing the actual files and scripts that we used for the webcam streamer. and just see if we can get an improved frame rate without having to use hardware encoding. So this is just a little Logitech camera, USB, but it will throw some errors, but it should still technically work. So we're going to try it, and the issue that I had with it is it's a 1080 camera opposed to it being a 720p camera. Also, the color's a lot better. But it should be something where we should be able to saturate the processor. So I'm going to try and place this up here. Let's see how we do with this. I'm placing it on top of my other camera, and I'm going to plug it into one of the USB 3.0 ports. Okay, there we go. All right, so now we're logged in through SSH, so now I can do copy and paste. So let's actually just install this, because I think it's going to work pretty well. And it's going to be a lot faster than trying to go through all this. I do kind of wish I made this an install script instead of just instructions, but I did want people to just do it. That way it would be something where if they're not familiar with it, they would be, you know, it would be more likely to get them into actually using the machine and maybe understanding the commands that they were running, opposed to it being something where you just kind of run something and things happen. So let's go ahead and configure our config file really quick. So we'll do ffmpeg run config, and now here's where we actually have to set this all. I realize all of this has line terminations. All right, we're going to change this to 1920. We're going to change this to 1080. We're going to do 30 frames per second. All right, and we're going to do hardware. It should still be 0,0, just as far as actually making it do what we expect. We can double check that as well. We're going to change it to 2 channels of audio. We're going to do 44.1. All right, and we're going to do output frame rate is going to be 30. We're going to keep 5 megabits per second, or 5000K. We're going to do MPEG TS, and we're going to change this. Instead of it being multicast, let's see if we can get it to my machine first. Did we not copy it over? We're able to install it. Right? It says service added. Or did I spell it wrong? Oh. It's an error within the script. That's the reason it's not running. All right. So it's a line ending issue. I'm not sure if it's going to run successfully, so let's take a look. It is there. Okay. So what's it saying? So we'll click to freeze it. Invalid data. Guessing channel layout. And just so you know, the reason why Logitech in particular doesn't like to actually process is because it has encoded H.264 data built in. And because of that, it makes it a bit of a deal because it's an additional field that FFmpeg is not actually programmed to handle. So that's the reason why this one is going to error whether we like it or not, but we want it to actually start. Okay, and it's the V4L2 M2M. So we actually want to change that. So let's actually go out. So everything else appears to be correct, just our output codec. So we're going to do vi/bin/ffmpeg run. And down here where we actually have it hard specified as H.264, we're going to do libx265. And we're going to try that. And we'll restart this. Go back in, and we do see that it is doing things even though it's erroring out. So we're going to clear out of that. Let's see if we can just receive it. So I'm going to go on my computer really quick, open up this port to be able to receive. Otherwise, I'll have to pull out a player really quick. Oh, yeah, we'll do the other Pi. That's what we said we were going to do. So pretty much putting the other image in the 4GB Pi. And let's get that started up as well. I will need to grab another HDMI and a network cable really quick. All right, and power. Let's move over our keyboard. And let's switch our screen. Right, so it's booting up. All right, and something I'm going to quickly do is I'm going to edit our config file because we need to send it to a different address. So let's actually try our multicast address once more. So we could do 239.1.1.1. Just kind of keep it simple. And I say that, but simple for that kind of thing is ridiculous. So we're back over here. We'll do media. We're going to do open network stream. We're going to do UDP : / @ 239.1.1.1 : 10,000. vi/bin/ffmpeg run. Let's change this to libx264. We will restart it. We'll do screen -r ffmpeg. Okay, it says it's doing things. Let's switch over to our computer and we see it. It is there. The color is still terrible, which I don't know what that deal with that is. But let's see if we can get this into full screen. Actually, what we may also want to do is get the output of this, because this looks like it's set to 720p. Right, so that's me centered on it. It's just a closer frame. But the color is terrible. I don't know why it's so bad like that, but I don't even think it's that bad generally. Now I do want to point this out. I think, no, I do have it. Let's see if we can maximize this. Look at that. Okay. So there we go. So this is us doing software encoding. So right now, if I go over to top, so we're still encoding, we see FFmpeg. It's using about 40% CPU, which is actually not a trivial amount, but also it's not using all of it. So we go back over here, we don't see any dropped frames, we don't see anything else like that. So I do want to try something. Let's just see what the overall latency is. So let me clap once. We don't hear audio from it, but you'll see it. So we see that it still has quite a bit of latency because in this particular case, VLC is adding some. Because we can go in here. Da, 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 da. Looks kind of clipped, but, you know, that's fine. The point is it actually doing the encoding that we think it's doing? And in this particular case, it definitely is. Let's take a look at this. We see everything is showing up properly in terms of what it's supposed to be. So the AVC, it's coming in MPEG-4, 1920 by 1080 at 30 frames per second. We can look at our statistics as well. We see it lost 0 frames. It was able to decode everything. It's coming in at our suggested bitrate. And if we look at the actual stats themselves, we do see it's pretty consistent as well. So overall, I do think that it is keeping up with the workload to be able to do video at full frame rate. I don't know about 4K yet, but theoretically, if you could get the 4K in, if you had an efficient codec or at least offloaded it through hardware somehow, it may actually be able to keep up with it. I know a lot of them will do motion JPEG out of the box as far as the the 4K little capture cards. In this particular case, I also have a capture card that is just USB, and this would actually be able to keep up with that as well. So let's see what we can do with the resolution here really quick. If we can get it up to 1920 by 1080. Right, because right now it's doing 720. So let's bring it up to 1920 by 1080. And we'll apply it. And we'll do OK. I'm going to try and close it out. Again, this is something where I'm trying to operate it through a another interface. All right, and now we can go full screen. So outside of the color, which I could actually fix that as well. Let's see. Oh my gosh. Yeah, the color here is absolutely atrocious. Okay, well, that's a bit better. This is me adjusting the hue on the input card, just so I could try and make it more normal. Okay, so this is a rough match, but at least it doesn't look as terrible as it did. I mean, it still looks pretty terrible, but let's see. I can go full Smurf mode, have a dance party. There we go. That's kind of normal-ish. But the sensor's not that great overall, so what are you going to do? But I think as far as being able to run this effectively, you know, it definitely has a lot more power than the Pi 4, which is what we were experimenting with last time. That could only do 24 frames per second. And I'm gonna pull this down because I feel like this is distracting for everybody. But yeah, so we see it's only using 40% of the CPU as it's actually doing this encoding, and that opens up the possibility, considering that it can do real-time encoding, to be able to overlay graphics, things of that nature, over live video, and be able to encode it and stream it somewhere. So a lot of advantages to be able to do that for applications like Earth cams, things like that. Like you want to be able to have it continuously stream a beauty shot, overlay some statistics about time and temperature, and then be able to send it to YouTube and the world. You know, you have the option to be able to do that with a Pi 4 that doesn't really consume all that much power, especially if you have to solar power it or things like that. And considering the onboard networking and everything else, I think there's a lot of versatility in this new hardware, and I can't wait to see where the PCI Express, peripherals and hats, how they're actually able to contribute to its performance as well. Because it's nice to run it off of an SD card, but this is also, they've expanded the bootloader to be able to give us additional options. So as an example, so if I actually switch back over here to the encoder, and let's see, I'm just gonna shut it down, or try to. And then I'm going to pull out the SD card and then start it back up. Now, assuming I get video, and it didn't just glitch. There it is. So this is the new bootloader. And it will try and boot off of every device. So it'll try and boot off of USB. It'll try and boot off of the SD card. It will try and boot off of an NVMe through PCI. So this is something that's going to continually loop. And even without shutting it off, if right now I'm going to put in the SD card with it still powered up, which I wouldn't recommend this, but just as an example of the fact that it's actually pretty nice, it starts booting. Wait for it. Right, so now it's reading. And now it starts booting. You know, so it's actually very weird. The fact that it's able to do it on the fly before it even boots up. And I know there's modifications that can be made to the bootloader, things like that, because they do have a restore image for the bootloader as well. So that is something that's very interesting to me, and I think is going to be something that, we're going to have to check out. So anyway, I definitely had a lot of fun today. So that's going to be it for the stream today. If you liked the video, be sure to hit that like button and leave a comment down below. If you know a friend or anybody who would be interested in this content, please share it with them. I would definitely appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot. And then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.